Hello, today we're going to look at some further graphing of quadratic functions. Now, yesterday we took a look at being able to find the axis of symmetry and the vertex, given that the quadratic function was written in a very specific form. But what happens if your quadratic function is given to you in standard form? Now, standard form, you might recall, is when we have f of x is equal to ax squared plus bx plus c. Sometimes this is also referred to as general form. Today we're going to talk about being able to take standard form and rewrite it in what I like to call vertex form, which is the form we looked at yesterday, where it's written as f of x is equal to a times x minus h squared plus k. Now we're going to use the same ideas that we used when we solved a quadratic equation, and we used the technique of completing the square in order to solve the equation. But this time we're going to use it to be able to rewrite one form into the other. So let's start with an example. Let's say that we want to sketch the graph of f of x is equal to x squared minus 4x minus 5. We want to be able to find the vertex and any intercepts. Okay, so this is what we're going to start with. We're going to start with the standard form. And instead of using f of x, I'm going to rewrite that as y is equal to x squared minus 4x minus 5. And I want to be able to rewrite it in vertex form. Now, there's several ways that this can be done, but I'm going to use the same technique we used for solving an equation. So you might recall the steps there. First thing we want to do is move the constant over to the other side. So this is going to become y plus 5 is equal to x squared minus 4x. Now we want to be able to complete the square on this side of the equation, and you need to ask yourself, what do I need to add in order to complete the square? You remember how to do that? We take 1/2 of negative 4 and we square it. So what I need to add to both sides is a plus 4. And we can add that to both sides of the equation. Now on the left-hand side, I end up with y plus 9. And on the right-hand side, I end up with x, and I want to factor this, minus 2 quantity squared. And so you can see up here from standard to this vertex form, remember I wanted x minus h quantity squared. So we have created that by completing the square. Now it's not quite in the vertex form yet because y should be by itself, or f of x, and so we want everything else on the right hand side. So now I simply bring the 9 over. So I have y is equal to x minus 2 squared minus the 9. And what I have here now is the vertex. I can read that right off of the equation. Thinking of transformations again, x minus 2, that's shifting it to the right 2 units. So my vertex is 2, and the minus 9 on the outside moves it down 9. So my vertex is 2, negative 9. Now we also want to be able to find any intercepts. These are often a little bit easier to find. So let's take a look first of all at finding the y-intercept. So if I want to find the y-intercept, I need to remember that I want to let my x equal 0. That's going to allow me to find the y-intercept. Now, if I look at my two equations, and we can look at them right up here, which form is easier for me to use to find the y-intercept? Well, both of them will find it, but I think you'll probably agree that this form is a little bit easier, because when I plug in 0 for my x's, 4 times 0 minus 5, it becomes that c value at the end. So y is equal to -5. So again, the point that I end up with for the y-intercept, and I always want to make sure I write it as a point, is 0, -5. And there is my y-intercept. Now, what about the x-intercepts? Well, for the x-intercepts, I need to remember that I need to let my y equal 0. So now I can look at it in one of two ways. I can either look at it as 0 is equal to x squared minus 4x minus 5, or I could let 0 equal x minus 2 squared minus 9. Remember, these both represent the same equation. Now, with the left-hand side, I can factor. I picked an easier one. So I have x minus 5 times an x plus 1. And notice I get x equals 5 or x equals -1. If I have it in vertex form, notice I can bring the 9 over. And 9 is equal to the quantity x minus 2 squared. I can take the square root of both sides, and notice I get 3 plus or minus, don't forget that, is equal to x minus 2. Solving for x, I get x is equal to 2 plus or minus 3. So notice 2 plus 3 would give me an x equals 5, or 2 minus 3 would give me x equals -1. So again, you could use either form of the equation to determine that your x-intercepts are at 5, 0, and -1, 0. So we now have our three pieces of information. We have our vertex, our y-intercept, and our x-intercepts. And we can put all three of those pieces of information onto a graph. So let's bring some graph paper into play here. So if I sketch my graph, I can plot these points. Now the vertex is at 2, -9. I'm going to have to go down here a ways for that. So 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9. There is my vertex. And then I have my y-intercept at 0, -5, 1, 2, 3, 4, 5. So it looks to me like this is going to open up. And I could tell that from the original equation because my a value was 1. And now my x-intercepts are at 1, 2, 3, 4, 5, 0, and at -1, 0. The axis of symmetry, again, I can dot in because it's going to go straight through the vertex. And if I sketch in my graph, it's going to look something like this. And I now have a much more accurate sketch of the graph because I also know how wide it is going to be. So this is one example of being able to sketch the graph of a quadratic function using the vertex form in order to find the vertex. We're going to look at one other way of finding the vertex in the next video.